Welcome to my channel, Physics Guru. In this problem, we're going to find out the speed of a proton when it passes through a potential difference. So here, we are given a potential that is 15 volt, and there is another potential surface that is a 5 volt. And then here you have a proton sitting at rest. Now, there is a force here onto this proton. So this proton will be attracted towards this 5 volt, or it will be accelerated towards the 5 volt. You see, the proton has a positive charge. So that means it will naturally be attracted towards the lower potential. So let me explain this problem here. If you have 15 volt and 5 volt, this is a lower potential and this is a higher potential. Or in other words, you can imagine this one to be 0 volt and this will be negative 10 volt. It's exactly the same thing. There is no difference. All it matters is the potential difference here. So if you assume this one to be 0 volt, then that's the negative 10 volt. And now you can see this is a negative 10 volt and that's the positive charge. What will happen? The proton will be accelerated towards this 5 volt. That means the speed of the proton will increase. When it comes to this 5 volt, it will gain speed because it is moving towards a lower potential. This is just like dropping a ball from a height. As the ball reaches to the ground floor, or it is getting closer to the ground, its speed will increase more and more. That's exactly the same situation we have here. If we release the proton, this proton will accelerate towards the 5 volt. And now how would you find what is the speed of this proton when it comes to this 5 volt potential? So let's first write down all the given numbers here. So the V1, that is the potential, is 15 volt, and V2 we call as V2, that is the potential 5 volt. Proton has a charge of this number here. That's the charge of the proton. This is the charge of the proton that is given. Okay, even if it is not given, this is such a basic number that you have to remember. That's the charge of the proton. And this capital V stands for the potential, and this italic and curly V stands for the speed. There is a difference. Do not get confused. Both are the V. This is for the potential and this is for the speed. So at this potential here, the proton has a 0 speed because it is starting from rest. You see here, that is given. It is starting from rest. So that means at this point, its potential is 0. And at this point, or at this potential, you have to find out the speed. So we do not know it. The mass of the proton is also given here. 1.67 times 10 to the negative 27 kilogram, and you have to remember these standard numbers here. So now what equation are we going to use? All we have to use is the conservation of energy. So what does this tell you? The total energy at this point, must be exactly the same at this point here or anywhere in between here. The total energy does not change. So all is happening here is the potential energy, the electric potential energy of the proton is changing into the kinetic energy. So it's just like if you drop a ball from a height, the total energy at this point, and this is the ground, will be exactly the same as at the ground here or anywhere in between. All is happening here is the gravitational potential energy is changing into the kinetic energy. But the total energy at any point is exactly the same. So let's write down that equation here. The kinetic energy plus potential energy, that is the total energy at this 15 volt, must be exactly equal to the kinetic energy plus potential energy at this point. The formula for the kinetic energy is given by half mv square. And potential energy formula is QV1. So remember the potential energy formula. PE stands for the potential energy, that is Q times V. That's the formula for the potential energy. It's QV. Half, that's the half mv square, again the kinetic energy, and this kinetic energy here is at 5 volt potential, and that's the potential energy now, QV2. And this V1 is 0 because we know that the V1 is 0, so this term will be 0. Q, what's the value of Q? We know here 1.6 times 10 to the negative 19. And V1 is the potential that is given here, 15 volt. Have the mass of the proton is also given, that's the mass. V2, we do not know V2, so we have simply kept it as V2 square. V2 square, V2 square, plus charge of the proton is 1.6 times 10 to the negative 19, and V2, that is potential at this surface, is 5. So now all we need to do is solve. So what I've done here, so I have taken this term on this side and changed and taken this term to the other side. So if I do the other side, it will be 1.6 times 10 to the negative 19. We have the same term here, and then it will be 15 minus 5. And now I can solve for V2. The V2 would be, if you see it is a square, then you have to take the 2 to the other side times this number divided by this number here. So just solve it. So if you plug in your calculator, the number you will get is this number here. Okay, so this is the speed of the electron when it comes to this point here, and this is this, you see, this is very fast here. This is fast. It's almost 43.7 kilometer per second. That means if you simply accelerate a proton between a 10 volt battery, then the speed of the proton will be 44 kilometer per second. That's how fast it is moving. So this is it from this video. I hope you understand. If you have any question, confusion, let me know, and do not forget to like, share and subscribe the channel. Thank you very much.